So students, today we are going to study a very important topic, that is refractive index. What is refractive index? That is when a light ray is passing from medium 1 to medium 2, right? Whenever it is passing from medium 1 to medium 2, so we can see that there is a change in angle, right? Either it will bend towards the normal or it will bend away from the normal. It just depends which medium is denser and which is rarer. So what is refractive index? We can define it as follows: the degree of change in angle when a ray passes from medium 1 to medium 2, right? This could be defined in this way. So how could we find a refractive index, right? A refractive index, according to Snell's law, that is second law of refraction, according to Snell's law, that mu is defined by refractive index, and it is equal to sine I by sine R, right? So through here you can also define refractive index. Suppose angle of incidence is given to you 30 degrees Celsius, 30 degree, right? And angle of refraction is also given to you 30 degree. So you can not 30 degree, I'll just change it. I'll take some other angle. I'll take 60 degree, right? We'll just put the values over here and we can find the value of refractive index. So sine 30 divide by sine 60, right? So sine 30 is 1 by 2, and we know that sine 60 is root 3 by 2, right? It is just cancelled out and the value becomes 1 by root 3. So this is your refractive index. So this is one of the way to find refractive index when angles are given to you, right? Sometimes they may give like angle 40 degree to which you are unaware about the values. Here the question comes, if we don't know the value of the, like sine 30 I was knowing it is 1 by 2, sine 60 root 3 by 2, but sometimes it could happen like it will come 40 degree. So I may not be the knowing this value. So what you can do is either the question will be giving you the value of sine 40, or what you can do is, if not given, then you can leave the question in this way only. Suppose sine 40 upon sine something 50 is there, so sine 40 by sine 50, you can just leave the question over here. This is how you can do. Mostly in most of the cases degree will be given to you. This is one of the case. And we have to understand one more thing, is that when the light ray is passing from one medium to another medium, there is a change in angle and there is a change in speed also. So we can define refractive index in this sense also. The change in speed when light passes from medium 1 to medium 2, right? From the medium should be changed. So for what is the formula for that? That formula is, first of all we have to define, like refractive index are of two types, right? In the case of speed we will define them into two types. First one is absolute refractive index, and second one is relative refractive index, right? So what is absolute and what is relative refractive index? We'll understand this thing. If we talk about absolute refractive index, it means that light ray is coming from air and going into any other medium, right? When a light ray is coming from air, means first medium should be air and it should be going into any other medium, like any medium, right? I should write here any medium. This is what absolute refractive index case. But in the case of relative refractive index, the light must be in any medium other than air. Other than air, it should be in any medium from medium 1 to medium 2. But medium 1 should not be air or vacuum, we can say. Then it is a case of relative refractive index, right? So now the point is how to find reflective index according to the speed. So how we used to do is, what we used to do, like if the ray is passing, if we talk about this absolute refractive index, we already know the ray is in air medium. So we'll write speed of light in air with respect to speed of light in any medium, right? And how does we write refractive index over here? Like I am just writing mu over here. This mu we can write in such a way, right? This is from air to any other medium, so I'm writing a mu, and this is any other medium, right? I'm just defining it by m. Okay, so this is how we can find the value. And when we talk about relative refractive index, it means light is going from any medium, like from glass to water. So what do we do? Speed of light in glass, and it is going to water, so we can write speed of light in water. You can just write in this way. Okay, so hence you can find the value. So here you must be noticing some things, some very important things you must be noticing. Why I am writing like this, a mu m or the g mu w? It is referring over here that light is going from air to any medium, and light is going from glass to water. From where it is going, that is written over here, and from where it is written over here, and the light going in which medium, that is written over here, right? It could be written in such a way also, like we'll just see it. Like if I am writing over here glass to water, light is going from glass to water, it could also be written in this way, like mu wg. Right? It could also be written in this way. There is just nothing difference. It is just shifted over here, and it is both the things are equal. This point is to remember, is very important. Many of the places this used to come. Right. Now one important concept we are going to discuss over here. One concept. There are many concepts, but one we are going to discuss over here. That is that whenever a ray is passing from medium 1 going into any medium 2, and if it is coming back into the same medium, like again in medium 1, so how we can write it down is, suppose it is going from air to glass and then glass again to air. So how you can do is, if you have not given the values of this basically speed of light in that, but you have to calculate the refractive index. So what you can do is, light is going from air to glass should be glass mu a is equal to 1. This relation is very important to know, right? So hence you can say that a mu g is equal to 1 upon g mu a. You can also say that like this point, g mu a has come downwards, right? So this is very important to understand, that light should come into the same medium back, then only it is applicable. Suppose if we talk about like medium 1 is there, it is going to medium 2 and it is going to medium 3, then this is not applicable. Medium 3, if these are different mediums, then this is not applicable. You can just write it down like it is air, glass, water. So light is going from air to glass. This is one other thing. Glass to water is another thing. Glass to water, right? This is another thing. So this is not applicable over here, right? And some numerical, I'll make one more video on which we'll be discussing some numericals on the topics, right?